Chapter 2.3 is about dividing mixed numbers, and the basic key idea to this one is good news because dividing mixed numbers uses all the same steps as dividing fractions. You just have that one additional step, and we did it with multiplying fractions. You need to remember to write each mixed number as an improper fraction first, and then you follow all the same steps as we did with dividing fractions. So the first step to dividing a mixed number by a fraction is to write any mixed numbers as improper fractions. And remember, when we do that, if we have 2 1/4 as our mixed number, then we multiply the denominator by the whole number because we have two groups of 4. So we do that, and then we add in our numerator for any extra pieces. So 4 times 2 is 8, plus 1 is 9, and then we keep our denominator the same. So our improper fraction is 9/4, and then we're just going to keep the rest of this the same for right now. So divided by 3/8. So step 2 is to flip that division sign to multiplication and flip the second fraction to its reciprocal. And remember that when we do that, nothing changes with that first fraction in terms of flipping it or changing it. And we are going to make that division sign multiplication like we mentioned, and then we're going to make 3/8 into its reciprocal. So we just flip that upside down. So it's 8/3. Next, all we have to do is multiply across. So we're going to take a look before we do that and see if we can cross simplify. So the 9 and the 3 do have a common factor that, they can both be divided by 3. So we divide by 3 up here, and 9 divided by 3 is 3. Divide by 3 down here, and 3 divided by 3 is 1. And then if we check the other side, we said it's like crossing the road both ways before you try to cross, or looking both ways before you try to cross, then we're going to notice that 8 and 4 can both be divided by a common factor of 4. And again, try to remember to find the greatest common factor, because some people would divide by 2, but then you would end up having to simplify again later. So 8 divided by 4 is 2 here, and 4 divided by 4 is 1. And for that next step, once we've cross-simplified, we're just going to rewrite those fractions like we've been practicing. So this one is now 3/1 times 2/1. In our last step, we're going to make sure that we've multiplied after we did all that cross-simplifying and rewriting. So 3 times 2 equals 6, and 1 times 1 equals 1. And then we also have to remember to simplify if it is any kind of improper fraction, and 6/1 is. So that becomes just 6 for our final answer. In example 2, we're going to be dividing two mixed numbers together, so we're going to follow all those same steps that we did in example 1. And so the first thing is to turn any mixed numbers into improper fractions. And this first one is 3 5/6. So we're going to do 6 times 3, which is 18, plus 5, which is 23. So we're going to have 23/6 here. And then we're not going to worry about flipping anything just yet. We're going to take this one step at a time, and we're going to turn this other mixed number into an improper fraction. So 3 times 1 is 3, plus 2 is 5, and that's going to stay over 3 for right now. And then we're going to now go ahead and start flipping things. So this time 23/6 stays the same, but we flip that division to multiplication, and we flip that second fraction to the reciprocal. So the reciprocal of 5/3 is 3/5, and then we check both directions here, and 23 is actually a prime number, so only 1 and 23 go into it, and 5 is also prime, so only 1 and 5 go into it. So if the only common factor is 1, we can't go any lower. But when we look in this direction, 3 and 6 have a common factor of 3. So we can divide them both by 3. So we're going to divide this by 3, and it's going to become 2. Divide this by 3, and it will become 1. And we'll rewrite that fraction as 23/2 times 1/5. And then we just multiply straight across. So 23 times 1 equals 23, 2 times 5 equals 10. And like we have been up until now, we remember to simplify. So we figure out how many times 10 can go into 23, which is 2 whole times. And then since 10 times 2 is 20, whoops, I wrote a division, but I meant that to be subtraction. So we are taking 20 away because we already used that with our 2, and we would have 3 left over out of 10. And we should always just double check that it can't go lower, but 3 and 10 don't have any other common factors besides 1, so it's as low as it can go. So even though we don't always do the estimating, one helpful hint is that you can estimate either before or after dividing mixed numbers to just see if your answer is reasonable. When you're estimating, we kind of use that basic halfway rule. So in this first mixed number, 3 and 5/6, if you look at just your numerator and just your denominator, if your numerator is about half or more of your denominator, then you can probably round up. If it's less than half, then you can probably drop that fraction off and just keep that whole number the same. So in this case, 5 is pretty close to 6, so it's definitely more than halfway. So we're going to round this first mixed number, 3 and 5/6, up to 4. And then the second fraction, 1 and 2/3, again, 2 is pretty close to 3. It's more than halfway over 3. So we're going to round that second mixed number up to 2. And when we're estimating, we don't have to deal with like flipping fractions or flipping signs or anything like that, because all you're doing is checking to see if it's reasonable. So 4 divided by 2 is 2, and we use this kind of squiggly sign to mean approximately equal to, because even though 4 divided by 2 is actually 2, this whole thing is just an estimate. And then we check to see, and if we think back to what the actual answer we came up with was for this problem, the actual answer we got was 2 and 3/10. And so when we compare those, we can kind of notice that the 3 is less than half of 10 anyway, so we would probably drop that off and make it just close to 2, and so that is pretty close to the estimate. Again, it doesn't solve small math mistakes that you might make, but at least tells you if you're in the right ballpark. I picked just 2 of the on your own problems this time, so I have them numbered as 1 and 3, but if you're looking in big green on page 72, there are 2 other on your own problems if you want some extra practice with the skill. Example 3 is using order of operations, and it's, again, just like we did in the last couple of sections, where we're just looking for which operation we need to do first. So we can see we've got division and subtraction, and we know our order of operations tells us we've got to do this one first. And then we'll just drop this one right down here because we're going to get to it later. And we're going to start by turning these mixed numbers into improper fractions. So 4 times 5 is 20, plus 1 is 21 over 4. And then we're going to just keep it division. We'll flip in a second. And then 8 times 1 is 8, plus 1 is 9. And again, that denominator is going to stay the same, so it's just going to be over 8. And then we're going to keep that first fraction the same, flip that second fraction and that division sign, and flipping them right at the same time. So now we've got the reciprocal of 9/8, which is 8/9, and that division problem has become multiplication. And again, we're just going to drop that minus 2/3 down so that we don't forget about it. And then we're going to look both ways to see if we can simplify. And remember, we've been talking about, even though 9 doesn't go into 21, what we're really looking for is common factors. And both of those do have a common factor. They can both be divided by 3. So we're going to do that. 21 divided by 3 gives us 7. 9 divided by 3 gives us 9. And then we'll check the other way too. And 8 and 4 both have a common factor of 4. So we'll divide by 4 and up here too. And this is going to become a 2. This is going to become a 1. And then we will rewrite to see where we're at. So we're at 7 over 1 times 2 over 3. And then we haven't forgotten about this part. We do have to remember to actually go through and multiply these now. So 7 times 2 is 14. and 1 times 3 is 3, and then we're going to subtract 2/3. And in this case, we got really lucky because we know we can't add or subtract fractions without common denominators, but in this case, they both happen to be 3, so we don't even have to change them at all. And so 14 minus 2 equals 12, and remember we don't actually subtract those denominators, we just keep it as a 3. And then we have to simplify by figuring out how many times 3 goes into 12, and it happens to go in exactly 4 times, so we don't even end up with a mixed number this time, we just end up with the whole number 4 as our final answer. Just a quick reminder when you're doing these, we know that they take a lot of steps and they look overwhelming, but if you just take it one step at a time and keep trusting that what you've been working on is going to come out correctly and you're keeping your work organized, it shouldn't be too tough to follow these order of operations questions. For the real life application, the problem says 1 serving of tortilla soup is 1 2/3 cup. A restaurant cook makes 50 cups of soup. Is there enough to serve 35 people? And then they do want you to explain it. So we know that the cook starts with 50 cups of soup, and then it's being broken down into serving sizes of 1 2/3 cups. So we have to actually divide that 50 by 1 2/3. So we're going to set up our problem first like this, and then we're going to check to see, depending on what answer we get, and see if it's enough to serve 35 people or not. First, we're going to turn everything into improper fractions, and in this case, that whole number can just get put over 1 to become 50 over 1. Keep with the division sign for right now, and then 3 times 1 is 3, plus 2 is 5, and keep that denominator 3. Next, you're going to work on the actual dividing, so 50 over 1 is going to stay the same. We're going to flip that division to multiplication, flip that second fraction to the reciprocal. Instead of 5/3, it's going to be 3 over 5. We're going to check both ways to see if we can cross simplify. 1 and 3 are already as low as they can go, but 50 and 5 have a common factor of 5, so we're going to divide by 5 in both cases. That's now going to be a 1. That's now going to be a 10. We're going to go ahead and rewrite that as 10 over 1 times 3 over 1, and then 10 times 3 equals 30 over 1, and that is the same thing as 30. And then lastly, we're just going to go back up to that original question to see if we've answered it after we did all this work. So it says in the question, is there enough to serve 35 people? And when we figured out the amount of soup that we started with, divided it into 1 2/3 cups, what we found is we can only serve 30 people. So our final answer here would be no. Just going to move that up here for a second. And so we would finalize our answer by saying no, you could only serve 30 people.